Today I'm going to solve another problem. Find subarray with a given sum k, and the array only contains non-negative numbers. Given an unsorted array of non-negative integers, find a continuous array which has to give a given number. Example is this array. And sum is 33, and we can find that the answer is this. Okay, so the brute force solution is to find each subarray and check if its sum equals to k. So that means we need to run a nested loop, and the time complexity will be O of n squared. And we are going to try to find a more efficient solution. And our aim is now O of n. So that means we should go for one loop. And when we are going through this loop, we should remember some informations which will help us to find the final answer. So what are we going to remember? We are going to remember indices because we'll need it for the answer. We are also going to remember the current sum. And update the current sum along the way. When the current sum equals to k, we can return our indices. So we are going to remember the starting index and the ending index, and current sum. Okay, let me draw this to have a better look. 1, 4, 20, 3, 10, 5, and k equals 33. So we can go from the start, and our index, ending index, and starting index are all here. So we can say the current sum, we set it to 0, and we can add 0 to the first element and update our current sum to be the sum of 0 and sum of current sum as, so update it as current sum plus nums I. So I is the index looping through the whole array. So then we can move I to the next. And so I is initially here. So we can move I to the next. And now we have a current sum. So now our current sum is 5. Right? So I'm going to write a table here. So when I is 0, our current sum is 1. And when I moves to 1, our current sum is 1 plus 4. So it's 5. And when we move I to the next, the current sum becomes 5 plus 20 equals 25. And next is 25 plus 3 equals 28. And then 28 and plus 10 equals 38. And 38 is greater than 33. So we have to stop here and try to drop something. So we have to drop the first. We have to drop the start because we need to maintain a continuous array. So that means we can only drop the start or the ending element, but we cannot drop the ending element because we have already checked from the start. From the start, we have checked every possible sum, and nothing had equal to k. So that's why we have arrived to 10. So there is no way we can subtract 10 and find the k. So what we're going to do is that if the current sum is larger than k, then we have to remove non-start. Okay, so then we will have a current sum equal to 37. It is still larger than 33. So we're going to check this again. Yeah, like before we check it again, we should check now if current sum equals to k. That means we can return something. But in this case, 37 is not equal to k, so we still have to go back to this part. So that means it is a loop itself. So we can have a loop here. Let me just write a while loop. So it's not if, it will be while. Okay, so 37 is here. It is still larger than 33. So we remove 4. 4 is the next start, right? So here we need to insert we need to start +1. So yeah, so start, so we remove 4. Now 37 minus 4 is 33. We go check this, and it is equal, so we can return now. Okay, so this is case 1, right? And we have another case. Another case is a equal case, and another case is the smaller case. So why not we just move this part here. What was it? If, right, if, okay. So this is the second case. And the third case is current sum less than k. That means we need to keep adding elements. So since we have already wrote this to add elements, we are just going to move I to the next element. So I plus plus, yeah. Okay, I think now we are ready to write some code. And the time complexity is all of them because we go for one round only. So we use the one loop to find our solution, our answer. And time complexity is all of one because we just use a current sum variable to store the information we need and update it. So it's just one container for current sum, and so the time complexity is constant. Okay, now let's write the code. I'm going to clean this out and write it here. And please ignore this part as there was some old code. Okay, so we need a variable called start. It is at 0 index. And we also need a current sum. We set it to 0 for now. And we are going for a loop. And I think the end is just the I, index I. So we don't need an extra n, which can just use I. So let's make I equal 0, and while I is less than the length. And then we are going to write the first case here. Okay, so while current sum is greater than k, remove start. So current sum okay, and next case is if current sum equals k, we can return so current sum if we can return the start and the end. And okay, so the third case is just else. So since here we have a return, we don't need to write else. But just in case, to be clear, I will write it else. So I plus 1. Okay, so we have a if and else. So we check this, and we check this, and we check this. So yeah, else should be right, but we can also just do this. Okay, so at the end, if we have returned nothing, then we return -1. That means no subarray is found with a given sum k. Okay, now let me double check if the code is right. Oh, no. We first need to update the current sum. Because our current sum is 0, and we should first add the first element of the array to the current sum. Not start, but I. Because when I plus 1, we need to add the updated element. Okay, it should be right now. Thank you for watching. Bye.